This is the phet simulation. I clicked on this link, got this page. All right, so temperature is the measure of kinetic energy. All right, so it's the kinetic energy of the particles. So when we do temperature, you can see in this simulation, if I click on this simulation here, if I add heat to it, the temperature rises, and so does the molecule movement. If I lower the temperature, take the heat, remove the heat from it, then you'll see that the particles are starting to move less. The temperature goes down. So there's a direct relationship with the temperature and the kinetic energy. So we're going to start with argon at a solid state. Click on the solid. And add energy. What's the next phase? So if we add this, notice that there's movement. They can move around each other, right? So it looks more like this, right? Liquid, not gas. Looks like the liquid phase. Cool argon until below its freezing point. Okay, so if we're going to make it where we have liquid, so we're going to cool it. So what's happening to the kinetic energy or energy of motion? Look at the temperature gauge. Which are the units to measure temperature? So this is in K, and that's Kelvin, right? So we could use a Celsius scale, but we're using K. When we remove energy by making it cool, what happens to the potential energy? Does the potential energy go up? I'm sorry, potential energy is, and kinetic energy. Kinetic energy is motion. Potential energy is stored energy. So if there's energy in everything, so if it's moving a lot, then the kinetic energy is going up. All right, so they're the opposite here. So potential energy goes up and the kinetic energy goes down. Right, so stored energy goes up and kinetic energy goes down. And the phase, right, goes from a liquid to a solid. Use the slider under the container to adjust the heat, increase the heat to observe the motion of the gas. What happens to the speed of the gas particles as you heat them up? So here's the gas. Okay. So the particles speed up or slow down here. All right, so we're going to have to use a different container here. All right, so this one has a pressure on the top. Okay, so we're going to go with a argon, and we're going to heat it up a little bit. And then we're going to push down the lid. And as we push down the lid, what happens to the temperature? See, we're at 84. We're pushing down. 93, 102, 215. As the volume decreases, the temperature does what? Does it decrease or increase? Click on each of the different atoms and molecules at the top. Observe the phase change diagram at the bottom right. So here's the phase change diagram here. So we go back to regular atmospheric pressure. Okay. So here is neon. So the phase change diagram is the phase change diagram the same for each atom. So if we look at this, so they aren't the same. If we look at the different the change from solid to liquid to gas is different. Along the very bottom, click on the states. Okay, so we're going to go back here. All right, so observe how gas particles move. Okay, solid, liquid, and gas. Observe how the gas particles move in each of the three states of matter. Neon, argon, oxygen, and water. Which of the states of matter are the particles moving the slowest? Okay. Solid, liquid, or gas? Solid, liquid, or gas? Solid, liquid, or gas? Moving slowest, solid, liquid, or gas. Along the bottom, click on the states. On the right side, click on each of the states of matter, solid, liquid, gas. Observe how the gas particles move in each of the three states of matter. Each of the matter, the neon, argon, oxygen, and water. Which state of matter generally has the least amount of kinetic energy compared to the two other states? All right, so the least amount of kinetic energy, like least amount of movement, going to be the one that moves the least. Which state of matter are the molecules moving around the most? Gas, liquid, or solid? All right, hope that helps.